Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at converting decimals to fractions. So we've already learned of the two types of decimals, terminating and recurring. So let's go through that. We'll start with a terminating decimal. Turns out they're quite easy to convert to fractions. So all you do is you write the number without the decimal point. So 0.85, I'll just write as 85, no decimal point. And then on the bottom, the denominator is the lowest place value. So 5 here is in the hundredths, goes tenths, hundredths. So on the bottom, we put 100. This number, 0.85, is 85 hundredths. So then you may need to simplify the fraction. Of course, 85 divided 5 is 17. 100 divided 5 is 20. So 0.85 and 17 over 20, exactly the same number. So that was quite easy, but unfortunately we can't use that process for recurring decimals. So the reason is for something like 0.36 recurring, there is no lowest place value. There is no last digit after the decimal point because these go forever and ever. Remember, 0.36 recurring is 0.363636. The 3's and 6's go on forever. So there's two ways that I'm going to show you, and it turns out one of these methods will work better for the first one and one for the second one. So if there are two numbers in the reptend, two numbers that are recurring, we say that the decimal period is 2. The decimal period is basically the number of digits that are recurring, the number of digits in the reptend. So when that happens, whatever the decimal period is, you make the denominator that number of 9s. What does that mean? If you have a decimal period of 2, if you have 2 digits here in the reptend, we're going to write it as something over 99. So what goes on the top? Well, we just write the digits in the reptend there. So it's 36 over 99. Again, we chose 99, 2 9s, because there were 2 digits that were repeated in the reptend. So once again, we need to simplify this if possible. 36 and 99 are both divisible by 9. It's 4 over 11. So that part was easy. So let's look at doing that method on 0.47 recurring. Note, if the dot is only above the 7, it's only the 7 that's recurring. So this is 0.4 and then 77777. Only the 7s are recurring. So this is going to be a little bit harder using this method because if you like, it kind of has a terminating part and a recurring part. So this is 0.4 plus 0.07 recurring. So 0.4, we can convert that to a fraction using the method up there. So 0.4 is just 4 tenths, and we can simplify that to 2 fifths. So 0.4 is 2 fifths. Now what about 0.07 recurring? Well, 0.7 recurring, we would just write that as 7 over 9. The denominator is 9 because there is one number in the reptend, one number that is recurring infinitely many times. So if 0.7 recurring is 7 over 9, if we want to find 0.0 and then 7 recurring, we need to divide that by 10. We need to take 7 over 9 and divide by 10. So 7 over 9 divided 10 is 7 over 90. So 0.4 and then 7 recurring is 2 fifths plus 7 over 90. So to add the fractions, we need to have the same denominator. We're going to times top and bottom by 18. 2 fifths, it turns out, is 36 over 90. Plus 7 over 90, and that gives us 43 over 90. So 43 over 90 and 0.0 recurring 7, they are the same number. So this way it was a little harder. Let's look at method 2 though. So we'll start on 0.36 recurring. So what we can do is we can let x be the decimal that we're trying to find. So I'll just let x equal 0.36 recurring. Now what I want to do is times this by a power of 10 so I get a number with the same decimal expansion. So if I times this by 10, it would be 3.63 recurring. I don't want that. I want a number that is 3/6 recurring in that order. If I times this by 100, what it does is just move the decimal point 2 spots. So 0.36 recurring, is 36, 36, 36, goes on forever. So if I times this by 100, I just move the decimal place 2 spots to the right. 100x, 100 times this number is just 36.36 recurring. So note here I have the same decimal expansion in both cases. That's really important because what I want to do is I want to subtract. I want to go 100x minus x, which is 99x. But then I want to subtract these two. And if I have the same decimal expansion, I'll get a whole number. 36.36 recurring minus 0.36 recurring just gives 36. So 99x equals 36. Solving that equation, dividing by 99, I get 36 over 99. And that simplifies to 4 over 11, just as I did before. So in my opinion, this way was much simpler for this one. But let's look at using this method in blue on this one. So here again, we would let x be 0.4 and then 7 recurring. Now what we want to do is we want to multiply this in such a way that we get the same decimal expansion. So we want to be left with just the recurring part, the 7 recurring. So if I times x by 10, I would get 4.7 recurring. So these two numbers don't have the same reptend. They don't have the same decimal expansion. But if I times by 10 again, I get 147.7 recurring. Timesing by 10, we just move the decimal point 1 spot to the right. Now I have two numbers here with the same decimal expansion. I can just subtract. 100x minus 10x is 90x. 47.7 recurring minus 4.7 recurring. All the numbers after the decimal point cancel out. I'll just be left with 43. And so I get x equals 43 over 90. Same answer that I had before. So in my opinion, this method was actually easier for this one. So when you have a situation like this where you have kind of a terminating and a recurring part, you might find the blue method easier. But when the numbers after the decimal place includes just the reptend, there's only a recurring part, it's probably easiest to use the first method. You can use whichever method you like. I just wanted to give you two so you'd have an option. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.